Back in the periodic table unit, you learned that this family has one valence electron and all of those elements lose that valence electron and become positive 1. The next family over all have 2 valence electrons, so they lose those and they become positive 2. We skipped all these yellow elements, these transition metals, because I said they do weird things. Well, today you're going to learn what those weird things are. What happens with those transition metals is that they have electrons in d sublevels, and they don't really count as valence electrons, but they can affect how that metal forms cations. They can either lose all of those d electrons, some of them, or none of them at all. Or they can take some of their s electrons and move them into a d orbital if that makes them a little bit more stable. So what that number of electrons that they lose, what we call that is the oxidation state. And transition metals have multiple oxidation states. Since they do, we have to be able to tell people which oxidation state we're talking about. And they do that by using a Roman numeral in parentheses immediately after the name of that element. The Roman numerals usually only go through 6. Roman numeral 1 looks like a capital I. Roman numeral 2 is like 11 with bars on top. Roman numeral 3 is 3 lines, and then at 4 is when you start using the V's. So you put an I before a V and then put the lines on top and bottom. 5 is just a V, and then 6 is a V with an I after it. So if something lost 6 electrons, you would say its name, and then you would put this Roman numeral 6 after it. The first one we're going to talk about, we're going to do one each day. The first one is going to be iron. Iron's symbol is Fe, and its atomic number is 26. Just for this purpose, we're going to make up our own electron configuration, which is going to be starting from a noble gas but finishing in orbital notation. So we're just going to do orbital notation for electrons 19 through 26. Argon has taken care of 1 through 18. So 19 and 20 are in the 4s sublevel. So here's number 19 and here's number 20. And then 21 through 26 are in 3d, which has 5 orbitals, and that means there's going to be 6 of them. There's 1, 2, 3, 4, 5, and then we come back to the first box and put a second one to have our 6. Technically, the valence electrons are these 2 4s electrons. So those are the ones that typically are lost, and when they're lost, iron Roman numeral 2, or iron with a +2 charge forms when it loses those 2 electrons in 4s. But if you look at what's left after those are gone, we have a situation where it's not really evenly distributed in the 3D block. Pretend like you're a perfectionist and this is bothering you, that that's not the same all the way throughout. What iron does is lose one of those d electrons so that every orbital has just 1 electron in it. When that happens, it's lost these 2 s electrons and 1 d electron for a total of 3. So it becomes iron Roman numeral 3 with a +3 charge. So it forms when it loses 4s and a 3d electron. And we would name that by putting the Roman numerals after them.